Hi everyone, let's continue learning Raspberry Pi Pico. Today we'll use SSD 1306 OLED display, which is using I2C protocol also. The hardware is like this. This one on the right side has 128 by 64 pixels, and on the left here has resolution 128 by 32 pixels. Both use the same chip and same protocol. Let's take a look at this one. It has 4 pins from left to right. Ground pin, VCC, SCL, and then SDA pin. The other one here is also have 4 pins with the very same order: ground, VCC, SCL, and SDA. We will first use this one. Please take a look here at my breadboard. I prepare 4 pins here. The leftmost pin is the ground pin, which will be connected to this ground line, and then followed by the VCC pin, which will be connected into the 3.3 volt line here. Then SCL pin will be connected into the SCL pin here. This is SCL pin, GP1. Then the brown one here will connect to SDA pin or GP0. Now we put this OLED display into the breadboard. Besides the hardware, we also need the software, which is SSD 1306 OLED library. This library will be installed from Sony IDE, and we will install that as a package. Now let's go to the Sony IDE now. We will continue using this code for the LED toggle. First of all, we will need to install the SSD 1306 package from here. Click Tools, Manage Packages, type in 1306 SSD 1306, search. Here it is. Click here, choose install. Then we will see here inside the lib folder there is ssd1306.py. We will modify this code. We will import also I2C from machine module. Then we will import from SSD 1306 library from lib.ssd1306. Please note that since this file is inside lib folder, then we have to write like this: lib.ssd1306 import ssd1306 I2C, like that. And then we will initiate the OLED display here. Width is 128, height is 64 pixels. Then I2C equal I2C ID 0. SCL pin is pin number 1. Take a look again here. The SCL pin is GP1, or the second pin, so we will write 1 here. And then SDA is pin 0 or GP0 here. Then we'll set also frequency 200,000. Then we will initiate OLED variable here, SSD1306 I2C with width and height. Use that variable. Weight width 8 and I to C as third parameter, this one. Then first we will turn on all the LEDs inside the OLED display with this command. Fill everything with 1, then show it. Let's take a look. We'll try to run this code. This code running well. It simply turn all LED inside the OLED display on. So we see here that some part on the top has yellow color and at the bottom has blue color. Let's continue. We will use default font here for our information. The default font has 8 by 8 pixels each font. So inside this OLED display we can display up to 128 divided by 8 is 16 columns or 16 font per row, and then because it has 64 pixels from top to bottom, then we will have maximum 8 rows. If we put the text without the gap, then we will have at max 8 rows. Now we will try to put some string on our OLED display. First fill it with 0. Then finally we will call show method. If we want to put some string, then we will call text function. Followed by the second parameter is the pixel offset from left. In this example, I just want to give it 35. And then third parameter is pixel offset from top. So when we write a command like this, then it will be printed on the very first row because it will be placed on pixel number 0 from top, and it will be placed on 35th pixels from left. We'll continue to put another text until it has 8 rows. Please see the third parameter here. At first row we give it 0, then for the second row we will give it 8, for the third row we will give it 16, fourth row 24, fifth row 32, and so on. The final 8th row will have pixel index 56. We will take a look. We will remove this one, then take a look at what happens to our OLED display. We can see here that we can write up to 8 rows inside this OLED display, but I think it's too scattered because we didn't give any gap between rows. I think it is too scattered to see 8 rows without any gap between rows. So now we will try to reduce the number of rows, and we will try to give 4 pixel gaps between rows. First, the first line here, we will set it to start at offset 4, then increase by 12 for each rows like this, 12, 24, 36, 48. Let's try this code. It's still not good in our case here because we have different color for the first 16 pixels here. The first 16 pixels have a yellow color while the rest have blue colors. So we have to omit anything below 16. So the second row will be started from 20. Then 12 row increase, 32, 44, and 56. Like this. We'll try. I think this one is much readable than before. We will have note here that for 8 rows, then the offset for each row will be 0, 8, 16, 24, 32, 40, 48, and 56. And for 5 rows like this, then the offset per row will be 4, 20, 32, 44, and 56. We will use this configuration instead of 8 rows like before, because it is, I think, looks much better. Let's run the code again. Then we will add a counting loop here like before. Print out the I value. Then we will write it down on the OLED. Fill with 0. Then add text. At the position 5 pixels from left and 20 pixels from top. Then we will add another text. I modulus 20 at 55 pixels from left and 35 pixels from top. Add sleep time here, 1 second. We'll see how it runs. The code runs as expected, and we will remember this offset when we use this kind of OLED display for 5 rows. Now we will also try to use another OLED display with a different resolution. The second one I showed you before. We will turn this off first. The OLED display has changed with a smaller version here. We have to change the resolution from 64.8 to 32 now. And then first we will try to occupy all of the 4 rows, because 32 pixels height means it can have maximum 4 rows. We will try to use that configuration first. So the first row will be on pixel 0, the second one will be on pixel 8, 16, 24. There will be no fifth row here because the display is too small to handle. We study the code and this is how it looks. It's also scattered and very hard to read. So we will reduce the number of rows for the 32 pixel height variant. We will try to reduce the number of rows into 3 rows only, and we will change this vertical pixel offset. The first one we will keep it on the 0 pixel, then the second one will be on 13 pixel, and this one will be on 25th pixel. We will not have fourth row here. I think it's much more readable right now. So we will have also note that for 32 pixel height variant, we will optimally have only 3 rows with offset on the 0, 13, and 25 pixels. Then we will continue to let it also count, but we have to modify this. 20th row is not possible here. We will use eight pixel from top should be okay, and this one 20 pixel from top should be okay also. Let's try it. Wait 5 seconds. Okay, like that. That's it for today. Thanks for watching.